Good morning, I am Narmatha, working in Dr. S.N.S. Lakshmi College of Arts and Science, in the Department of Cybersecurity. In today's lecture, we are going to discuss about Data Encryption Standard. So, it is an algorithm used to perform encryption and decryption operations. So, it is mainly used in block cipher. Let's see that. Data Encryption Standard. So it is a most widely used block cipher in the world. So most of the people are using this algorithm to perform encryption and decryption. It is adapted in 1977. So it encrypts 64-bit data using 56-bit key. It has widespread use. It has been considered controversy over its security. So when comparing with other algorithms, most of the people will refer this because it has security. Data encryption standard history. So IBM developed Lucifer cipher by team led by Feastel in late 60s. We had developed Feastel cipher structure. So it uses 64-bit data block and 128-bit key. Then we redeveloped a commercial cipher with input from NSA and others. In 1973, NBS issued request for proposal for a national cipher standard. So IBM submitted their revised Lucifer, which was eventually accepted as the data encryption standard. Data encryption standard design controversy. So we can call DES as a standard. It is accepted by the public. It was considered controversy over design because here we have used the concept of facial cipher structure. So in the choice of 56-bit key, Lucifer uses 128-bit key. And because of a design criteria were classified, here what we have used means we are eliminating a 64-bit key every 8th bit. In that only we are getting a 56-bit key. So subsequent events and public analysis shows that in fact design was appropriate. So the main use of DES as flourished, especially in financial application. So it is still standardized for legacy application use. So the overview of DES encryption is given here in this picture. Okay, so we are sending we are taking a 64-bit plain text. First, what we are doing means we are performing the initial permutation. So after performing the initial permutation, it performs 16 rounds of operations. So in every round, permutations and substitutions will be performed. Okay, so here we are splitting a right hand side and left hand side. So for both the sides, we are performing the permutation operation and substitution operation. After performing all these things for every 16 rounds, at last we are swapping the values what it is produced by that all 16 rounds. So after that swapping, we are inversing the initial permutation, then we'll get the ciphertext value. So initial permutation, first step of the computation is initial permutation. So it reorders the input data. So what we have given, so that will be reordered by the initial permutation. Even bits to left hand side and odd bits to the right hand side. So quite it is regular in structure. Here we didn't use a cryptographic value. Round structure is specified in this. So it uses 32-bit left and right halves. As for any facial cipher can be described, Li is equals Ri minus 1. Ri is equals Li minus 1 and F of Ri minus 1 and Ki. F takes 32-bit R half and 42-bit subkey. So it expands R to 48 bits using perm E and adds subkeys using XRs, and it passes through 8 S boxes uh, and to get a 32-bit result. Finally, what we are doing means we are performing the permits using 32-bit permutation. So here the round structure is explained in this. So we are splitting the plain text 64-bit into 32-bit left hand side and right hand side. So after splitting that, we are performing the initial permutation. We are reordering the values. Then we are including the key. After that, we are performing substitutions and permutations. And at last, we are performing the swap operation. So here the simple picture is given. 32-bit right hand side. So we are encrypting. So we are using 48-bit key. We are performing the XOR operation. Then it passes through all the rounds and we are performing the permutation. After performing the permutation, it produces the 32-bit value or a data. Thank you. So from this lecture, you can understand about the concept of uh, data encryption standard and how we are performing the initial permutation and the 16 rounds. What are all the things we are doing in that 16 rounds? So that will be explained clearly. Thank you.